In the late 1970s, when punk came up, the Sex Pistols, I had a guitar in my hand, an electric guitar, and had drums, I had everything. And we formed a band which was named Chaos, and we made loud and noisy music. We played Highway to Hell, which came out 79, has only 2 accords, A and G, so it's pretty easy. So I tortured the guitar. And I had people around me who could play pretty well. I'm not sure if they were aware of my ambitions to be a rock star, my very short time ambitions. They probably, like most parents, would not have been happy with that, because that doesn't give you a secure kind of income. So naturally they were very happy when I did go to university. Yeah. We had one concert and people were not so amused. So we better thought we do some better contributions to this world.
5, 4, 3, 2, 1. And we have engine ignition.
Engine start and liftoff. The SS Kalpana takes flight, sights set on the International Space Station.
It is Australia's first space experiment on the International Space Station, which is Australia-led and officially NASA listed. So it's the first, none before. I come from a small town in Germany, a village. Never thought I will be doctor, never thought I will be professor. It made me proud. It was also, you prepare for 1.5 or 2 years. You feel now it's going to be happen. Now you think now it really moves through, and it's fascinating to see this rocket going up and think, oh, my small samples are also on it. You see it going in the sky, and it gets more blurry, and at the end it's just shining like a star. You have to know, when you are a space expert, there's only launch attempt, because many launches fail. We sat there with champagne, expensive French champagne, Moet, and with the whole press team, less than 2 minutes, 1 minute 50 or so before the launch. It was already a bit, when the rockets gets a bit active with a little bit of dust and so, this is not good, and they had immediately to stop, and we sat down and said, hey.
LC on countdown 1, abort, abort. There's LC on countdown 1.
And as you heard, we have an abort, no launch tonight.
We sat there with our champagne, our marketing team, very optimistic, want to give applause, and then it was stopped and everybody was coming down from space to reality. And this shows how difficult technically, even today, space launches are. The second launch was in the night time or evening time on Saturday. So we didn't come together because not everybody likes to work on Saturday. So I saw it alone at home. I had my private launch, made photos. And we had a second launch because the Miser tablets did go up later, 1 year later. Known that the medicines in space decompose generally faster, not always, but generally faster in space. And people say this is due to the presence of the cosmic radiation. We have cosmic radiation in space, that is alpha particles, which are protons or helium cores, that is beta particles, which are electrons, and maybe best known to the public are gamma particles, which is something similar to X-ray, but a very aggressive version of X-rays. They're present here on Earth, but they are naturally filtered here by our magnetic field. That's why we can survive. Now, in space, we have them more or less unfiltered. And when we are in a spaceship, we can exclude even some of the radiation, like alpha particles, because they are very well absorbed by materials, but the gamma radiation, for example, goes through. So my point then was, we used something which is known on Earth to be able to protect medicines, and that we do by coatings. Yeah? We take a tablet, and around the tablet, you put a thin shield, a thin coating. On Earth, you do it usually for other reasons, but we could do that to protect the medicines in space. So we had one drug, ibuprofen, and we had one coating, but we systematically varied the composition of the tablets. Yeah, the tablets have 5, 6 ingredients, which are called excipients in scientific knowledge, in it, that can be as simple as silicon dioxide, which is sand, basically. And those ingredients we varied systematically. We thought it's a good idea to have heavy weight atoms in it. Ideally, that would be lead. Yeah, it's a very heavy weight, but lead is poisonous, so we could not take it. Ideally, that would be uranium, but for obvious reasons, we also didn't take it. So we took iron, finally, iron oxide. This is in the Mars regolith, so in the Mars soil. We thought that's a good choice. I think nobody before us did a really systematic study. When we made the samples for the ISS experiment, it was at the top of the COVID time, I think in summer 2020. And you have to imagine the situation. You come in buses with the mask, it's far away. The buses are pretty empty because hardly anybody was allowed to go to work. And we come here at university, which is usually a very crowded place. Everything is totally empty because all people were forced to stay home. We had an exemption, luckily, by our dean to work. When I say we, it's me, 2 students and another co-worker. So we 4 desperate persons came in the morning in the laboratory. Everything is empty. So basically, I found we are here on space. We are doing this on Moon while preparing a tablet for the Moon in a way. It gave a kind of bizarre feeling. So like we are lost, we are alone.
The Cygnus spacecraft for this space station resupply mission was dedicated to Kalpana Chawla, who was the first woman of Indian descent to fly in space. Chawla, who devoted her entire life to understanding flight dynamics, lost her life during her second spaceflight, the STS-107 mission, when the Space Shuttle Columbia disintegrated upon re-entry into the Earth's atmosphere. You can now see the robotic arm. It is ready and in position to reach out and capture the Cygnus cargo vehicle today.
Table 5, in a way, crystallizes all what we did. You see 6 formulations there. They were put outside ISS.
Inside the International Space Station, the crew is conducting experiments all the time. Did you know there's a lot of testing happening on the outside of the station as well? Other times when we can't effectively simulate the harsh environment of space, the materials are flown 220 miles up to the International Space Station to Missy X.
The Missy project is the longest running materials technology development project on the International Space Station. And MISSI stands for the Materials International Space Station Experiment. It's actually a series of materials flight experiments that are placed into trays. Materials or experiments that are in these trays get exposed to the space environment for a long duration.
You prepare two kinds of samples. One goes to the rocket, obviously, and the other stays on ground. But it doesn't stay here in Adelaide, so we put it in the same airplane, which sets the samples from Adelaide to the company Space Tango in US, and it stays over there. So it has the same history of age and shaking in the airplane. The airplane, it might be colder or warmer than normal, so it shares that. And then it's sent back after the samples splash down. So this is something which is thought to be of good credibility for the experiment.
Table 5, in a way, crystallizes all what we did. The numbers in the table, they come from the UHPLC, from the liquid chromatography. This is ultra-fast chromatography. And there you see components are separated into several peaks. Each peak belongs to one molecule. And then if you have standards, you can quite surely say this peak is ibuprofen, and this peak is this decomposition product. So we could identify that a major toxic known decomposition product of ibuprofen was formed in quite high amounts. The cosmic ray action is not only to take the ibuprofen out. I mean, that would be easy. We just give a little bit more ibuprofen and the astronauts have always enough. But it forms toxic side products. That's also written in all your paper which you get when you buy a medicine, and these toxic products increase with time, and you should be aware when you take a medicine you might also take toxic products.
4 of them are red flags, so they were seriously, the truck was seriously destroyed. One is orange, which means not too bad, and one is yellow, which means it is not undestroyed. It would be green if it would be undestroyed, but it has a level of decomposition which is not so far from Earth. If you leave your ibuprofen tablet in your shelf in the kitchen for 1 year, you will also have a destruction in the order of several percentages. Yeah? So it's quite something. So this is the good sample, this is the iron-coated sample. And if you just compare where all compositions are given, we see a lot of yellow and we see green. This is inside ISS. But there we didn't have so much decomposition of all samples because naturally the astronauts also live there. So the level of radiation is low and the medicines are less affected. So table 5 is a final proof that our concept were good. And if I can mention that the orange sample contained from our partners, the University of Nottingham in England, flavor molecules. These are terpenes, and they are known to be very good oxygen radical scavengers. And cosmic radiation makes oxygen, aggressive oxygen. Aggressive oxygen has a radical function which can react with crucial components of the human body. That also happens when you have cancer. We have aggressive form of oxygens, and scavenger captures these aggressive forms. It binds it, so it's out of the game. That is a funny thing that helped to improve the stability of the tablets.
We learned something, not only about the coating, but about how to design a proper space tablet.
Our study is just a part or a small part of many papers about space medicine, and we continuously try to improve our knowledge over there to help astronauts in space. The Australian Space Agency, 2 or 3 years ago, they also formed a kind of space medicine crew to advise them, and I'm luckily part of that. So it has been recognized here in Australia as competency in space medicine. It's not only me, there are several other colleagues contributing. So we formed a kind of spearhead here for space medicine, and that will go on. So that is the impact of such experiments to advance the technology, but also to create awareness for the topic among the many topics we have. We have space mining, we have satellites, so good experiments create awareness for a topic.
What do you like about space and the space sciences? What is it that piques your interest? Because you have such broad interest, but this one has come up to the top.
Yeah, yes, it came to the top. That has a reason, yes. I like no man's lands. Yeah? I like something like Columbus came to America, which is completely undiscovered. I think I'm good then to pioneer topics. I'm maybe not so good in detailed research when everything is already quite known. Yeah? So space naturally offers a lot of frontiers. It offers extremes, yeah, the temperature, the vacuum, and so on. And I like extremes, and that motivated me. And I discovered with time that it's not so much alone about going to space, making experiment there, thinking in space terms, the vantage point. It changes the mind how I make research. And I think many people still have not discovered this. I emphasize this in every talk of me, that you do research differently and probably you do research better. And for the vantage point, you don't have to go 100 kilometers outside to see the blue Earth. It's certainly great. But the vantage point is a virtual one, is a mindset one. I think it's always good to be first. I mean, in science, the ones who make the first paper, and if it's reasonably good, they are many times cited. People refer to it, so you are probably remembered. It's not so much about me, but my work is probably remembered longer. And actually, since nothing is discovered, it's for a good scientist relatively easy to find something exciting, yeah? So I think that is a feeling. We talked about music, yeah? When there was the first rock and roll music, Bill Haley or so, and then Elvis Presley, they had a wide and open space and they could shape it. I think it's a matter of creativity. If you're creative, you will like it. If you do research in a more routine fashion, you will like something where other people already have set the standard and where you can refer to something and do not fear to make a mistake. Naturally, in a no man's land, you can make a lot of mistakes. Yeah. And I never thought it would get doctor, really, never. I know I could hard work, that I definitely know harder than most others. So I thought I would work hard, not too intelligent, but still enough. That was my feeling, really. So like a mountain, you climb until there's something where you really think there's no way. I thought I cannot manage it, but I thought I'd give it a try until they really fire me. I have to give my most sincere and my warmest regards to a few persons and institutions who made this space experiment happen. And that is, first of all, Jana Staudemeyer from Space Tango, who was a personal contact, and without her I simply could not have made this experiment. To name the second company, Aegis Technology, so they are the ones who made the space experiment on the Misse platform. Space Tango made it on the ISS. Then I have to give my warmest regards to the two students who are on the paper and who helped our experiments. They worked for free in this COVID times. That was a great help, guys. And to my co-worker, Nam Tran, who also helped at this point of time. I have to give my regards to my school and to my faculty, who gave me the exemption to work and the trust in us and to allow the experiment going on. Finally, I have to give my regards to the Andy Thomas Space Center, where I'm research director with John Colton as a director, who were very supportive to our research. I want to round this up also to thank the CEO of Space Tango, which is Twyman Clements.